Welcome to this explainer. Just a few short years ago, we collectively thought that true creativity was the absolute last uniquely human trait. Painting a masterpiece, writing poetry, composing music, or architecting incredibly complex software, that was our domain, right? Well, today, machines are doing all of it. And honestly, they're doing it with a speed and proficiency that is genuinely breathtaking. We are standing right at the edge of a fundamental shift in how technology operates. But the real question we need to ask is, how did we actually cross this threshold?
Seriously, how does a machine actually create something brand new? To understand how this is even mathematically possible, we have to completely peel back the illusion of magic. Because, spoiler alert, it's not magic at all. It is a cocktail of highly complex math, billions of dollars in specialized hardware, and frankly, more data than a human could read in 1,000 lifetimes. Today, we're going to break down exactly what is happening under the hood, step by step, to show you how these breakthroughs have completely changed artificial intelligence forever.
All right, let's dive into part one, from rules to learning.
For decades, software was stubbornly rigid. It operated purely on explicit, rule-based instructions written out by human programmers. Think of traditional software kind of like a strict recipe. If a single step or even a minor ingredient is missing, the whole thing just fails. The computer could only do exactly what it was told, and literally nothing more. Generative AI, though, it completely threw that old playbook out the window. Instead of a strict recipe, it acts a lot more like an apprentice chef. Using artificial neural networks that are actually inspired by the human brain, we stopped giving the machine explicit rules. Instead, we fed it massive datasets, say 10,000 pictures of cakes, and basically asked it to figure out how to bake one by finding the underlying patterns itself. It transitioned from a system of blind obedience to a system of active, dynamic learning.
Now, generative AI didn't just happen overnight. It's essentially a 70-year overnight success story. Back in the 1950s, we had these early, super ambitious conceptual dreams of artificial intelligence. Fast forward to the 1990s, and we saw the growth of basic machine learning. Then the 2010s brought us the deep learning era, where neural networks became incredibly sophisticated. This is the era that effectively gave AI vision, allowing it to finally recognize objects in photos. But then we hit the 2020s, which triggered this massive, explosive boom that gave AI language. So what triggered this? Well, one very specific mathematical discovery changed the entire trajectory of the technology forever.
Which brings us to part two, the transformer breakthrough. The absolute secret sauce behind the current AI boom is an architecture called the transformer model. Before transformers were introduced, if an AI was reading a book, it would literally forget the first chapter by the time it reached the third. It read strictly word by word, in order, which just destroyed its ability to retain any real context. The transformer changed everything by introducing what's called an attention mechanism. This essentially allows the machine to look at an entire paragraph at once and mathematically weigh the context of different words simultaneously. For the very first time, the AI could understand that the word bank means something entirely different when placed next to the word river than it does when placed next to the word money. It finally unlocked true context.
So how does this actually operate in practice? First, the machine takes in data, like a prompt you might type, and breaks it down into pieces called tokens. Think of tokens, not just as whole words, but sometimes as syllables or even short chunks of letters. Second, it applies that brilliant attention mechanism to map out the exact mathematical distance and relationship between every single token. Finally, it uses that intricate map to predict the next piece of the puzzle. At their core, large language models are really just the world's most sophisticated autocomplete. They calculate the most statistically probable next token based on literally everything they've ever read. But to predict accurately, how does the machine actually learn what makes a good prediction?
Let's look at part three, how the machine learns.
To truly wrap our heads around the modern AI ecosystem, we have to split its digital brain into three distinct phases. First up is training. This is the incredibly heavy lifting of building the AI's core intelligence. It involves processing massive datasets, essentially scraping the entire public internet. And it takes months running on giant clusters of hardware. Then there's inference. This is the phase you actually experience when you type a prompt into an AI tool and it generates a response. It requires significantly less computing power. Finally, we have fine-tuning, which often uses something called reinforcement learning from human feedback, or RLHF. Think of RLHF as the AI's etiquette school. Without human feedback guiding it, a raw AI might generate totally unhelpful or erratic text. Human evaluators step in to shape that raw model into an assistant that is actually safe and useful.
And guys, building these foundational models is a monumental undertaking. According to verified data from the Stanford AI Index and McKinsey, this training process isn't just mathematically complex,
It requires literal billions of dollars in upfront investment. We are talking about nation-state levels of funding just to purchase the highly specialized computer chips required to run the foundational math. The physical footprint of this revolution is truly staggering. Just look at the timeline. Back in 2021, enterprise AI spending was at a relatively standard baseline. But starting in 2022, the demand for specialized processing chips, called GPUs, completely skyrocketed, pushing global data center growth to its absolute limits by 2023. The parameter counts, which are basically the number of connections inside these artificial brains, are getting so incredibly huge that tech giants aren't just building new servers anymore. Get this, they are currently negotiating to keep entire nuclear power plants online just to fuel the electricity grid required to train the next generation of models. Moving on to Part 4, a general-purpose technology.
We have officially moved way past the era of AI acting as some simple novelty chatbot. Because it is multimodal, meaning it can process text, images, and code all at the exact same time, it has become a general-purpose technology. It's embedding itself right into the bedrock of our economy, much like electricity or the internet did before it. In healthcare, it isn't just taking administrative notes anymore, it's spotting microscopic anomalies in X-rays that human eyes might completely miss. In software development, it acts as an ever-present co-pilot, writing the foundational code so human engineers can focus on high-level architecture. It's accelerating scientific research by predicting complex molecular structures for new drugs, and it's even seamlessly integrating into enterprise robotics. Yet, for all its amazing ability to generate incredibly human-like output across every major industry, we have to look closely at a really critical contradiction. The very thing that makes generative AI so incredibly creative, its ability to fluidly predict patterns rather than rigidly retrieve hard facts, is also the source of its biggest flaws. Why? Because it doesn't actually know anything. It's just guessing really, really well.
And that leads us to Part 5, limitations and future frontiers.
Because these models are probability engines and not literal encyclopedias, they suffer from what researchers call hallucinations. If they don't have the exact answer, they will confidently invent one that statistically sounds correct. Furthermore, because their intelligence is derived entirely by absorbing data from the public internet, they mechanically mirror whatever is in that data. If the internet contains biases, and we all know it does, the AI mathematically reflects and amplifies those biases right back in its outputs. On top of that, we are grappling with deeply complex copyright and privacy issues, the enormous energy consumption we talked about earlier, and the scary mechanical reality that these systems can be used to generate automated misinformation at an entirely unprecedented scale.
This mechanical reality brings us to a massively crucial concept: AI alignment. Alignment is the entire field of research dedicated to ensuring that these systems operate predictably, safely, and in a way that actually aligns with human instruction. And listen, this isn't just some abstract academic problem. It practically determines whether the AI assisting in a medical diagnosis, managing a smart financial grid, or operating an autonomous vehicle operates reliably and safely when faced with totally novel situations out in the real world.
As we look forward, we absolutely must clearly distinguish today's reality from tomorrow's frontier. Today, our current reality is incredibly sophisticated pattern matching. We use AI to assist human workers in generating text or code. But the future frontier, the thing tech companies are spending billions to achieve right now, is artificial general intelligence, or AGI. That's a system capable of performing literally any intellectual task a human can. We are moving from simple assistants to autonomous AI agents. To put that in perspective, today you might ask an AI to write out a recipe for dinner. Tomorrow, an autonomous agent will be given a goal, invent the recipe, connect to the internet to order the groceries, and schedule the delivery, executing a complex multi-step plan entirely on its own without you lifting a single finger.
Ultimately, what we're witnessing is the culmination of humanity's relentless pursuit of intelligence. Think about it. The printing press distributed knowledge, the internet connected knowledge. But generative AI, it is the first tool in human history that actually generates knowledge. It is fundamentally changing not just the physical tools we use to do our work, but the very nature of how ideas, discoveries, and creativity are formed.
The future is arriving faster than ever, and you now have a solid understanding of the mechanics running under the hood. You know how the data moves, how the math calculates, and what makes these systems both absolutely brilliant and inherently flawed. But it leaves us with one vital, unanswered question to chew on. As these systems grow exponentially more capable, the ultimate question isn't what the machine will do, it's how humanity will choose to wield it. Thanks for joining me on this explanator. Keep questioning and stay curious as this incredible technology continues to evolve.
Thanks for watching World Decoded. Make sure to like and share, subscribe, and stay curious.